Hello and welcome friends. In this particular module, I wish to discuss about Theodolite traversing. The brief outline of my presentation will be introduction, traversing, selection and marking of the stations, linear and angular measurements, their compatibility, methods of traversing and locating the details. As you learn the content, you will decide the compatibility of linear as well as angular measurements for theodolite traversing, as well as you will be able to demonstrate the use of theodolite for traversing by various methods and hence to look at the details. Already we have discussed about the traverse. As you know, traverse consists of series of several lines connecting successive stations. The points defining the ends of the traverse lines are called as traverse stations or also traverse points. The distance along the line between successive traverse points is determined either by direct or indirect measurement, or the distance could also be measured by electronic distance measuring equipment. The traverse could be of two types. One is open traverse. It starts at a known station and terminates at a point of unknown station. Whereas the closed traverse, it originates at a known station and closes on another known station. The variety of these particular traverses, the way you see here, this is closed traverse. Here, this is also closed traverse. This is also closed traverse. Here it is open traverse. This is also open traverse. So, depending on the kind of the feature that we wish to study, we can go for open traverse or closed traverse. The method of the traversing is convenient. It is a rapid method for establishing horizontal as well as the vertical control, particularly when line of sights are short due to heavily built up or say wooded areas where triangulation or trilateration like techniques are not feasible. However, if the work demands high accuracy, say for example, if we think about city surveys to look at the establish the boundaries, sewerage networks or any such network, say if we wish to establish certain supplementary horizontal control for topographic mapping surveys, in order to have location as well as this particular construction layout surveys for major projects such as highways, railways and other private as well public works. Also, the technique is beneficial to establish the ground control survey for aerial kind of surveys. As far as theodolite traversing is concerned, the total fieldwork that is involved can be categorized under these particular headings. Firstly, reconnaissance. Again, while discussing about the chain traversing as well as compass traversing, already we have discussed about this particular term. You know that this reconnaissance is the basic step of the surveying which is associated with thorough understanding of the area and the total scope of the work. Subsequently, for theodolite traversing, we have to select as well as mark the stations. We have to measure the traverse lines. We have to have angular measurements and simultaneously we can pick up the details that we are interested in. Typically, in case of theodolite traversing, we need a person who will be handling the theodolite with three personnel who will be assisting him. The kind of the equipment that we need is theodolite, ranging rods, steel tips, chains, arrows, markers, axe, hammers and pegs. Typically that axe, hammers, pegs, markers, etc. Already you know that these are mainly involved during the reconnaissance stage of the work. So, having understood the concept of the reconnaissance, we will directly switch over to this particular selection of the survey station as far as Theodolite traversing is concerned. Here, the basic principle of the surveying should be strictly observed. As you know, the basic principle of the surveying is to work from whole to part. We wish to establish the entire control over the piece of the land to be surveyed, and then we go into the parts of it. And the second principle is to establish the station by making use of two independent measurements, and we can have the third measurement in order to confirm the location of that particular station. So these principles should be strictly observed as far as selection of any surveying station is concerned. In addition, the stations need to be mutually intervisible. We wish to work in the forward direction, we wish to work in the reverse manner. So accordingly here they should be intervisible. We wish to set the equipment, we wish to walk along the survey lines. That means we should deal with certain firm as well as plain ground which won't let the sinking of the equipment. The survey stations as well as the lines should be as few as possible. It is obvious that as we go for a particular station, it will be helping us to define the entire network of that particular survey lines. As we induce that particular number of the station, that means that many times we have to set the equipment, we have to level the equipment, we have to center the equipment, and this is the place at which the errors could be involved. So the number of stations should be optimum, I would say. In addition, here the length of this particular survey lines should also be as long as possible, covering the entire scope of work of area. This goes with our earlier discussion, that is choosing the optimum number of survey stations. Even the network of this particular survey lines should be compatible with the nature of the feature and well defined. Say for example, if we think of this particular kind of the features we wish to survey, the kind of the network that we have considered here would be beneficial. Otherwise, one could have gone for some say bigger networks which would be unnecessarily attracting more work and more cost and more time. Hence, to have the resources effectively utilized, we should have this particular network of survey lines should be well defined and should be compatible with the extent of that particular features. As well, it should involve minimum site clearance. So in the nature point of view, in the protection of environment point of view, to save the resources point of view, this point is very much essential. In addition, the survey stations that we choose should facilitate the measurement in between as well as recording the various features, because in order to record these particular features, we'll be referring to the various stations as well as survey lines that are defined by them, and hence the line should be as close to the features so that the length of the offset or angular measures would be beneficial with the principle that we wish to follow for that kind of the surveying. So the first thing that we wish to have after choosing the stations is marking of the same. This marking of the stations will vary from station to station. The way you see here, for ordinary works we can drive the peg. Now we wish to center the theodolite, so we can drive the null. If we are dealing with some particular station which needs to be permanently marked, so here just we can have that particular say steel peg encased. We need some concrete block. We can, if we are working on that particular say pavement kind of the thing, we can drive the circular tube, we can plug the same, we can mark certain cross mark. If we are working in the mountainous region, if the patch is rocky, then we can have this particular kind of the markings as well. Even we can erect the signals kind of thing. So depending on the site situation, we can go for variety of ways in order to mark that particular stations. Here the way you see, the stations could be permanent as well as semi-permanent, but all the way it could be ordinary, permanent, permanent, maintenance. Here the station should be easily recognizable not only during the surveying work, because as we discussed in the project works, will be in need of such station markings during the execution, operation as well as maintenance phases. So here that way here the station should be say that the station should be permanently marked as such. Even if that kind of permanent marking is say not possible, here we can provide some such a kind of site plans as well as this kind of location sketches. So on the site plan itself, here we can have the station positions marked, and accordingly in order to catch their particular position we can refer to the permanent objects that are lying around that particular station. So two dimensions will be helping us to mark that particular station, and the third dimension will help us to confirm that particular location. So here we have to go for reference site plans as well as the location sketches. As well, especially for the signals, the way you see here this particular rod is placed above the station marking. So here as one is expected to sight this vertical stem kind of thing from very long sides, we have to be very cautious to see that this particular vertical portion will be lying exactly above the station under consideration. Say for example, if we are dealing with the triangulation networks, trilateration networks, so at that time here this kind of precaution is very much necessary. Next stage will be taking the linear measurements. So as discussed previously, we can make use of taping, chaining, as well we can go for echometric methods, we can go for electronic distance measuring equipment in addition to total station as well as even the laser meters. The way each of these particular heads is concerned, please refer to the channel. You will find the relevant material for each of these points. For angular measurements, again we have discussed lot many things about the theodolite. You know about the horizontal angle measurement by repetition, reiteration and such things. If you are going for the EDM kind of the equipment, or if you are going for certain digital theodolite like equipment, here the processes are discussed elsewhere over this particular channel, you can refer to. But as far as this particular traversing methods are concerned, that are having certain peculiar arrangement as far as the measurements are concerned. So here these particular traversing can be done by using the loose needle, fast needle, included angles, direct angles as well as deflection angles. Again, let me say that this particular discussion is more related with the academics. Practically, one may not follow this, but these are basics of surveying. These are principles of surveying that have been laid by all the old surveyors. So here we must understand what are that particular basic methods, because this particular discussion will help you to develop the surveying attitude further. So first thing, that is loose needle method of bearing. Here the direction of the magnetic meridian is defined at each traverse station. So the way you see, say if we are dealing with this kind of a traverse, so at each of these particular stations we'll be defining that particular say magnetic meridian by making use of say prismatic compass, and accordingly as bearing is defined at each traverse station, we'll be measuring the bearing at each of that magnetic meridian. Obviously, if each of these particular magnetic meridian is influenced because of the local attraction, then here the bearing measurement will be not compatible with theodolite expectations. Hence, the method will be very inferior. Another method is fast needle method of bearing. Here, in this kind of traversing, direction of the magnetic bearing is defined only at the starting station. So, the direction of the traverse lines, that is the bearings, are defined at first traverse station only with respect to that magnetic meridian. Whereas, magnetic bearing of all other lines are indirectly determined by making use of the bearing initially observed on the first station and the included angles that have been measured at each of the stations. In this method, vernier remains clamped with respect to initial setting of magnetic meridian. This method is accurate and usually preferred. In order to facilitate traversing by fast needle method, one can follow different approaches. Say for example, the first approach is direct with transiting. So in this case, let's assume that we have started the work from station P. We have defined the magnetic bearing for line PQ. As such, we have measured the magnetic bearing of this particular line PQ with respect to the magnetic meridian that is defined at station P. So without disturbing the plates, it is expected to shift the equipment at station Q. Here we will loosen the lower plate and again we will bisect the station P. As you know, as we loosen the lower plate, there won't be change in the readings. The upper plate remains clamped. As such, when we transit, the telescope, it will be in the direction of line PQ continued. So here we can have the bearing of QR measured. So in the same manner, we'll move to R. We'll have the backside on the station Q by loosening the lower plate. We'll have the telescope transited and we'll continue the way we perform at station Q. Another method is direct without transiting. So in this case, we set the equipment, we measure the bearing of line PQ. Without disturbing the plates, we shift the equipment to station Q. We loosen the lower plate. Again, we bisect the station P. So here the line of sight will be 180 degrees out of the orientation. Here we loosen the upper plate and rotate the telescope and have the foresight on station R. So to obtain the bearing of the QR, we add 180 degrees if the vernier reading is less than 180 degrees, or we deduct the 180 degrees if it is more than 180 degrees. So same operation can be continued as we move to R, S, T, etc. The third method is method of back bearing. Here again, as we set the equipment at station P with respect to the magnetic meridian, we measure the magnetic bearing of the PQ. Without disturbing the plates, we shift the equipment to station Q. We loosen the upper plate and set the vernier A to read the back bearing of line PQ. As we set the back bearing of line PQ, we release the lower clamp and bisect the station P. Now here the upper clamp will be released and we sight our next station R. So here whatever that particular bearing is fed with respect to that, here we measure the bearing of line QR and subsequently here we continue in the same way. This approach is very commonly used. Here we define the direction of the magnetic meridian only at the starting station. So here now only we will be measuring the included angles at each of the stations, the way we discussed about method of precipitation, that is face left thrice, face right thrice, and we have that particular angles averaged. So by making use of initial bearing, we work out the bearing of all other remaining lines. So the way you see here, the traverse is run in the anti-clockwise direction, P to Q, Q to R, R to S, and accordingly. Whereas here, essentially, this is done in order to measure these particular angles in clockwise direction. So here we have set the equipment initially at P. We have determined the bearing of this line PQ. As we set the vernier A to read 0 with the backside on U, we can measure the included angle UPQ by repetitions. So here this particular process will help us to facilitate the angle measurement at each of these particular stations. Next method is method of direct angles. This is especially useful when we are dealing with the open traverse. The way we did earlier, here the direction of the magnetic meridian is defined only at the initial traverse station. Whereas, as we move ahead along the traverse, we'll be measuring angles only directly, that is angles to the right only, and by making use of that angles we'll be computing the bearings of lines. So the way I mentioned, it is used for open traverse and the angles are read clockwise direction only. Another method is method of deflection angles. So here the direction of the magnetic meridian is defined at the initial traverse station, whereas all the deflection angles are measured and bearing of all lines are determined. Here the concept of angles to the right as well as deflection angles has already been discussed. Just to have again the brief revision, here in order to measure the deflection of line QR, we take the reference to its backward line, that is line PQ, and the angle through which it is deviated at the connecting point is expressed as angle of deflection. So the way you see here, whenever the equipment is set at station Q, will be sighting to station B, will be taking the backside and transiting the telescope, and angle alpha will be measured. Same process will be following. So the way here you see, here the angle could be required to be measured towards the right, or angle could be measured towards the left. The angles measured towards the right are considered to be positive, whereas the angle which is measured in the anti-clockwise direction are referred to be negative. So all the methods that we discussed, maybe loose needle, fast needle, so all that are essentially for the continuation or to have the travel along the series of servolites. Here, as we are more interested in locating the details, we have to take a reference of all that are the servolites. So here again we will be making use of second principle of survey. So in order to mark a particular feature under consideration, we can make use of angle and distance from the same station. We can make use of angle as well as distance from different stations. We can make use of angles measured at two stations simultaneously. We can measure simply the distances x and y in order to mark that particular station. We can have the feature defined by making use of, say, oblique offset or perpendicular offset. As such, by knowing the angle and length, by knowing the chainage and offset length, we can define the point. Or otherwise, if the features under consideration are wavy, if they are irregular in nature, we have to take number of such offsets. important concept is to observe the compatibility in between linear and angular measurement. In the simple words, say if we wish to measure angle precisely and if we are measuring the respective chain lengths or survey lines by using some inferior means, it will totally hamper the precision in the work, and as such, having inconsistent state of the measurement, it will be sheer wastage of resources. As such, the precision of the angle measurement as well as the distance measuring equipment should be consistent, that is, they should be compatible with each other in order to have the resultant effect should be similar on the desired output. In order to understand this particular matter, say we wish to plot this particular station R by making use of this inclination alpha and distance d with respect to station P and say this survey line PQ. If both alpha and d are correct, we'll be able to mark this particular station R very correctly. But as you know, all the measurements are subjected to instrumental, manual, atmospheric errors. Both the measurements will be somewhat erroneous. Hence, this R won't be plotted as exactly R, but through that particular say delta alpha effect. That is nothing but the error in angular measurement and the distance measurement delta d will cause this R to be shifted as R dash. Here, this R dash can be quantified as d tan of alpha. Whereas this particular displacement due to the linear error, as I mentioned earlier, is nothing but delta t. In order to have this particular consistency maintained, this delta d should be equal to d tan of delta alpha. Here, for small angles, this delta d by d can be considered to be simply delta alpha. This particular expression helps us to define the compatibility. For example, if we are making use of 20-second theodolite, the corresponding consistent linear measurement should be delta d by d. That is, here as we are thinking about this particular 20-second theodolite, that is the list count is 20 second, tan 20 can be considered to be 20 second, having that angle small. So 20 into 1 by 60 by 60 into pi by 180 will be the radians. As such, here the corresponding linear dimension should be 1 in 10,300, say 1 in 10,000. The case can be easily understood more, say if we are going for 30-minute compass, then this kind of the precision won't be required, because the way you see the calculation, here the compatible linear measure is just 1 in 100. So here if you are going for say compass for traversing kind of the thing, it's better to go for say steel tape, not the steel tape, steel chain or some such means, say some steel band we can make use of. Whereas if you are going for that particular Theodolite traversing kind of a thing, we have to preferably go for steel tape and have the distance measured in the forward manner, in the backward manner, in order to facilitate the proper plotting of the features. So I hope concept is clear. So thank you for your attention. I hope all the concepts that I discussed here are clear to you. As we move ahead, having known the basic traversing technique as well as traversing methods for Theodolite, now we would move ahead with traversing computations. So bye till then, I wish you very happy learning. Thank you.